Alrighty, in our last lecture for the semester, we're going to be talking about 9.5 inverses of matrices. It's our last way of learning how to solve for matrices and brings back the determinant in a sense of why did we even look for the determinant? Well, the determinant does help us find the inverse of a matrix, and then we can use the inverse to help us solve for equations. One thing to note is I represents the identity matrix, which for a 2 by 2 just looks like this, but for a n by n, basically is a diagonal of ones. Something like that. Or it's just a diagonal of ones and a whole bunch of zeros as triangles around it. So that means that if I find the inverse of a matrix, we denote it as this. So this is the inverse. And I would equal the inverse times its original matrix and then original matrix times inverse. So that should be commutative if the inverse truly is 8 to the negative 1. I think it's about all the notes in there. So let's kind of jump into one. We start off in the homework by just simply being able to write system of equations as a single matrix, which you've kind of done this already, but in a different formatting. So we got 14x minus 5y equals 7, and we have x plus 9y equals 2. We're going to be on page 623 today. So what we do to convert this is we're going to kind of start off our coefficients. So we got 14, 1, negative 5, 9, and then we're going to close it there. We're not going to add the equal part. And then we'll just have a single matrix of x and y. So we have a 2 by 2 and a 2 by 1. That would basically be row, column. So it turned back into that. And then it would equal this 2 by 1 matrix, 7 and 2. So if we knew the value of x and y, it would equal the 7 and the 2. So this is a different way to write it, and that's kind of what they want you to practice at first. So if you look at number 5, we have 3x1 minus 7x2 plus x3 equals negative 4. And then we have x1 minus x2 equals 2. And ax2 plus 5x3 equals negative 3. So that give us 3, 1, 0, negative 7, negative 1, 8, 1, 0, 5. Then we close it, and then instead of x, y, z, it'd be x1, x2, x3, and that would give me the result of negative 4 to negative 3. So again, another way to represent our matrix. All right, so let's get into the meat of today, which is finding the inverse. So let's look at number 13. To find the inverse, let's start off with just A, B, C, D. If this is the matrix A, the inverse is 1 over the determinant of A times the matrix. We're going to flip the D and the A, and we're going to change the sign of C and B. And so that would be 1 over, right? Yeah. That would be what the matrix would be. So with that said, let's look at number 13, which is 0, negative 5, 4, negative 1. All right, so here it is. So the first thing we have to do is determine the determinant. So we will do some work. So the determinant would equal 0, because we would multiply this diagonal, minus 4 times negative 5, which is negative 20, which makes that positive, so that gives you 20. As long as the determinant's not 0, it has an inverse. If you get the determinant of 0, then it does not have an inverse. So in this case, this would be 1 over 20 times, I'm going to flip A and D, so now negative 1 goes here and 0 goes here. Change the sign of B and C. So this has now become a positive, and this now becomes a negative. Then we just distribute, so your final inverse would be negative 1/20. 4 goes into 20, what's that, 5 times, so that becomes negative 1/5. 5 goes into 24 times, so it's going to be 1/4. And then 1 times 20 is 0. So you do want to simplify your fractions, but that's pretty much all you got to do. All right, so let's do a few more of these. So let's look at 14. We have -2, -2, -1, and 2. First determine its determinant. So -2 times 2 is -4, minus -2 times -1, which is +2, which gives us -6. So it does have a determinant. So we do 1 over -6. We're going to flip A and D, so this becomes 2 and -2. Change the sign of B and C, so this becomes 1 and +2. And then we will multiply the scalar. So 2 times -1/6 gives me -1/3. 2 times -1/6 gives me -1/3. 1 times -1/6 gives me -1/6. And -2 times -1/6 gives me +1/3. And that would be it. Let's keep going. Let's look at number 15. Got 3, 4, -4, -5. Let's look at the determinants. So 3 times -5 is -15. Minus 4 times -4 is -16. So that gives me +1. So I get 1 over 1, which mainly I don't have to do anything. Change the sign of 3 and negative, or change the places of 3 and -5. So -5 goes here, 3 goes here. Change the sign of B and C, so it becomes 4 and -4. And when you multiply that, you end up just getting the same result, which is really nice. So that would be the inverse. All right. So that's pretty quick and easy for 2x2s, but let's talk about the big ones, which are the 3x3s. So let's look at number 19. -2, 1, 4. -4, -4, -3. -2, 1, 4. So when you are looking for the inverse of anything other than a 2x2, the best thing that we can do is set this equal to the identity matrix. And basically what we're going to do with that is now turn this side to the invert, or the identity matrix, and whatever is left, or whatever is over here, will become my inverse. So we basically got to do Gaussian elimination, but like a lot of it. All right, so kind of review from that. We can't flip rows. Okay, so the best thing I can do is to turn this guy into a 1. So we're going to do row 1 divided by -2. So that's going to be 1, 2, 1. 1 divided by -2 is -1/2. You're going to be dealing with lots of fractions, by the way. And then we got 1, -4, 1, 0, 1, 0, 4, -3, 4, 0, 0, 1. All right, next thing I want to do is produce a 0 here and a 0 here. So I'm going to do negative row 1 plus row 2. And then I'll do -4 row 1 plus row 3. So row 1 will remain the same. All right, so -1 plus 1 is 0. -2 plus -4 is -6. -1 plus 1 is 0. -1/2 plus 0 is 1/2. 0 plus 1 is 1. 0 plus 0 is 0. -4 plus 4 is 0. -8, 9, 10, 11 gives me -11. -4 plus 4 is 0. -4 times -1/2 is actually +2. So that gives me 2, then 0, and then 1. Okay, here we go. Next test, turn this into a 1. No, I lied. Next test, turn this one into a 1. Row 2 divided by -6. 0, 1, 0. 1/2 divided by -6. That would be -1/12. -1/6. 0. 0, -11. 0, 2, 0, 1. All right, now I'm going to do 11 times row 2 plus row 3. Again, my goal here is to turn this one into a 0. So 1, 2, 1, -1/2, 0, 0, 0, 1, 0, -1/12, -1/6, 0. So 11 times 0 plus 0, 0, 11 plus -1, 0, 0 plus 0 is 0. -11/12 plus 2 be 24 minus 11, which would be negative. No, it'd be positive 13/12. -11/6 and 1. However, I can stop here. The moment you get a row of zeros, it does not have a inverse. And the fact is that we have to do all that work just to determine that it can't be done. All right. Let's look at another one. Let's look at number 20. We're gonna do the same thing. I promise this time it does work. So we get -3, 2, 1, 0, 5, -5, -4, 4, -2. First task, make this a 1. So we get row 1 divided by -3. So that's going to be 1, 0, 4/3, -1/3, 0, 0, 2, 5, 4, 0, 1, 0, 1, -5, -2, 0, 0, 1. All right, so the next goal is to make these both zeros. So I'm going to do -2 times row 1 plus row 2. And then this would be negative row 1 plus row 3. So -2 plus 2 is 0. 0 plus 5. -8/3 plus 4/3. Oh, my bad. So -8/3. Okay. Plus 4. I wish there was like an automatic. So it's 6 2/3. So what's that going to be? 23. Let me see if that makes sense in my head. I don't think it does because that's -8/3 plus 4. That would give you 4 would be the same thing as 12/3. 12/3. No, it can't be. Can't trust a calculator, man. All right, so you get -8, and then 4 is the same thing as 12. So -8 plus 12 is 4/3. Why is this not making sense in my head? So let's see, -8/3 plus 4. Oh, that's right. Okay, that's weird. And then we get 2/3 plus 0, and then 1, 0. And then this would be now 1, or -1 plus 1 is 0. 0 plus -5 is -5. -4/3 plus -2. So I get 2 negative divided by 3, -2/3. I don't know where I'm at anymore. -4/3. Okay, so we get -4/3 plus -2, and I get -3 1/3. That's -10/3. Yeah, I like that. And then it would be 1/3, and then 0 and 1. All right, let's see. Make sure we don't make so many mistakes. Now I want to turn this one into a. Oh, I lied. I want to turn this one into a 1. Row 2 divided by 5. All right, I think I'm going to go to a different calculator. Desmos for the win. All right, so I have 4 divided by 3. And I am doing what? I'm dividing that by 5. It gives me 4/15. And then 2 divided by 3. Divide that by 5. Gives me 2/15. And then 1/5 and 0. All right, my next task, get this to become a 0. Doing that, I'm going to do 5 times row 2 plus row 3. All right, so I get 5 times 0, which is 0 plus 0. 5 times 1, which is 5, plus -5, which is 0. And on this one, I get 5 times 4/15 plus -10 divided by 3. Ooh, nice clean number of -2. All right, next one would be 5 times 2/15 plus 1 divided by 3 gives me a nice clean 1. And then 5 times 1/5 is 1, plus 0 is 1, and then 0 plus 1. Alrighty, next task, make this become a 1. Row 3 divided by -2. Okay, so far we didn't get a row of zeros. So my next goal would be to make this become a 0. So I'm going to do -4/15 times row 3 plus row 2. And I should be able to also do, yeah, I will. I should be able to also do -4/3 times row 3 plus row 1. I should be able to knock this out in this last move here. So this right here will stay the same. This one's done. And now let's do row 2 first. So -4/5 times 0 plus 0 is 0. -4/5 times 0 plus 1 is 1. -4/5 times, or 15th, sorry, plus 4/15 is 0. Now this is where it gets magical. So this would be -4 divided by 15 times -1 divided by 2 plus 2/15. That gives us 4/15. All right, then we're gonna do the same thing. We're gonna do -4/15 times -1/2, but this time add it to 1/5, and that gives me 1/3. Then I'm going to take that plus 0, and it gives me 2/15. And then now I'm ready to do this one. 0 plus 1, 0 plus 0, this negative plus positive gives you 0. And then the big question. Take -4 divided by 3 times -1 divided by 2. 2. Right? Plus, what was up there originally? -1 divided by 3. I get positive 1/3. Plus row 1 would be 0. I get 2/3 across the board. And that right there would be your answer. That's the inverse of a 3 by 3. Not any fun. All right, let's finish up this lecture. Let's look at number 37. We're going to solve this using inverses. So the way this looks like is you're given something like this: -2x minus 2y, -x plus 2y. Oh, forgot the equals 9 and equals -3. We're going to do what we did at the beginning of this lecture. Then we're going to convert it to the notation of -2, 1, -2, 2, xy, 9, -3. And so what we have to do is, to get rid of this guy, we have to find the inverse of this 2 by 2 matrix. So to find the inverse, and you start off with the determinant. I mean, -2 times 2, which is -4, minus 2, which is -6. So then I get -1/6. Switch these two places. So that's 2 and -2. Change the signs. That's 1 and 2. So I get -1/3, -1/3, -1/6, and +1/3. That would be the inverse. So what happens next is I'm going to do this. -1/3. I'm only going to do this once to show you. And then I'll skip this step. I'm going to multiply this matrix on the left side of this matrix. And if I multiply it on the left side, I also have to multiply on the left side of this side. This right here ends up being the identity. So then I'm left with X and Y. And so I just got to figure out what this answer is. So -1/3 times 9 is -3 plus 1. So -3 plus 1 is -2. -1/6. Oh, bring out the calculator again. -1 divided by 6 times 9 plus 1 divided by 3 times -3. I get -5/2. And that right there would be it. So another way to solve for your X and Y is by finding the inverse and multiplying the left side of the equation by the inverse, and you get your answer. All right, let's do a couple more of those. Let's look at number 38. This is 3x plus 4y equals -2. -4x minus 5y equals 9. Again, I'm going to convert it. So 3, -4, 4, -5, x, y, -2, 9. Find the inverse of this guy. So 3 times -5 is -15 minus -4 plus 4 or times 4 is a -16, so it makes it a +16, which is 1. So therefore, the inverse here would just be -5, 3, 4, -4. I feel like we did these already. So I'm going to take this and I'm going to multiply it to this side. So this now gives me, actually, I'm going to take this now on this side just to go ahead and do the work. So this gives me -5 times -2, which is 10. That 1 divided by 1. When I multiply it out, it just ends up being the same. So I didn't have to worry about that step. -5 times -2 is 10. And then -4 times 9 is -36. So 10 minus 36 is -26. And then 4 times -2 is -8. 3 times 9 is 27. So that should give you 18. Right? -8. No, 19. Hmm. All right. And that right there would be your answer. I actually don't remember how they want your homework. I think the homework actually wanted you to write it like this. Just know that these are both the same thing. I think it wants this one. I can't remember now. All right, last question of the semester. Number 39. We get -2x plus 3y equals 1. 4x minus 6y equals -2. -2, 4, 3, -6. X, y. 1, -2. Find the determinant. That'd be -2 times -6, which is 12, minus 3 times 4, which is 12. 12 times 12 is 0. If the determinant's 0, there is no inverse, so there is no solution. Solve the following system by the inverse matrix method if possible. If the inverse matrix doesn't apply, use any other method. Okay. Well, we were almost done. So I can't use the inverse method because the inverse does not exist. So now I have to try a different method. Let's see here. I'm thinking the substitution would probably be, nah, probably elimination. But however, I multiply this by 2, that would cancel, that would cancel, that would cancel. Okay, so this is going to be an infinitely many solutions, but they're going to want it as a equation. So you just got to solve, you got to pick and choose which one you want. I'm going to go with, let's solve for x. It doesn't really matter which one you solve for, but you do have to solve for one of them. So I'm going to subtract the 3y over. 1 minus 3y, divide by -2. So therefore, if x equals this, so it goes like this. If you remember, if you solve for x, then you're going to plug in the equation. So 1 minus 3y divided by -2, comma y. If you solve for y, then it'd be x, comma the equation, such that y is a real number. So basically, whatever value of y you choose, it can be any value you want, and then it will determine what the x value is. And that is the conclusion of chapter 9 and the conclusion of this semester. Next up is your semester exam, which will be opening soon, or I guess depending on when you're watching this video. Yeah, I believe it opens up on the 8th, due on the 15th. So it opened up this following Monday. So if you're watching this video, it is already open. Practice test is already open on it too. I think it opened up last weekend. But due on the 15th. Once the 15th passed, there is no, I forgot to do it. I forgot to turn in my work. It's done. I finalized my grades on the 16th and submit them to Lamar. Other than that, that is all that I have. But as you are finishing up this semester, if you still got questions, feel free to email me. Let me know how you're doing. Other than that, that is all that I have for this video. I love to say I'll see you in the next one, but not this semester. You would have to take another one of my courses. Yeah, have a good one.